welcome to our maths class for today. In continuation of our trigonometry series, we are talking today about Pythagoras Theorem. What does this talk about? What does this Pythagoras Theorem, what does it state? Pythagoras Theorem mainly deals with right angle triangle. Like we said, the longest side facing the right angle facing the angle 90 is the hypotenuse. Then we have opposite angle, we have the adjacent, which can be changeable. Hypotenuse is constant, the longest side facing the angle 90, while the opposite can be either this way, can be B or C, and the adjacent can be C or B, depending on which angle is in question. Pythagoras theorem states that the hypotenuse, the square of the hypotenuse, is equal to the square of the adjacent and the opposite. So A square equals B square plus C square. That's all what Pythagoras theorem states. So if we have, we are given a side of the right angle triangle without being particular about any of the angles, and then we're given another side, we can definitely find the third side. Let's look at questions to buttress this Pythagoras theorem. Let's look at a question like this. We have this is 6 centimeter, this 5 centimeter, this 4 centimeter, and we are asked to look for this angle A, B, C, and then we have D here. We are asked to find angle. We are asked to find angle A, the line AD to the nearest millimeter. Well, we are given something like this, and we have to look for this first before we look for this. So let's say our angle BD square will be equal to 5 square plus 4 minus 4 square, because line BD square plus BC square equals this. So this will give us 25 minus 16. So BD square equals 9. So BD equals square root of 9. And that will give us 3. And it is 3 centimeter. Now, we want to look for AD. AD. How do we get AD here? We look at the bigger triangle, AC, ABC. So in triangle, let's come this way. In triangle ABC, AC square equals AB square plus BC square. This is a bigger triangle. AC square, the hypotenuse side, equals AB square plus BC square. What's AC square? C square is equal to AB is what we are looking for, plus what's BC? 4 square. So AB, line AB square equals 6 square minus 4 square. That's 36 minus 16. That will give us 20. So AB equals square root of 20. Now, so from here to here is square root of 20. So how do we get AD? So AD equals line AD equals line AB minus DB. What does that give us? AB is root 20 minus 3. DB of BD is 3. What's root 20? That's 4 times 5 minus 3. That's 2 root 5 minus 3. Now, 2 root 5 minus 3. What's 2 root 5 minus 3? 2 root 5 minus 3, root 20 will give us minus 3. Root 20 will give us 4.472 minus 3. Now 4.472 minus 3, that will give us 1.472 centimeter. And we are asked to give our answer in millimeter, so that will be 14.72 millimeter. So to the nearest millimeter, that's 15 millimeter. This is an application of Pythagoras Theorem. Let's look at yet another question. The sides of a rhombus are centimeter long. The sides of a rhombus are 17 centimeter long. If one of the diagonal is 30 centimeter, if one of the diagonal is 30 centimeter long, what is the length of the other diagonal? What is the length of the other diagonal? What's the rhombus? The rhombus looks like this. Then the sides of that rhombus 17 centimeter long. Now these are the diagonals. The line that divides the shape into two equal halves. And then the diagonal is 30 centimeter long. So from here to here is 30. So it means this will be 15 centimeter. This will be 15 centimeter. What is the length of the other diagonal? This other diagonal. Look for this. 17 square equals x square plus 15 square. This is the hypotenuse. 17 centimeter. The sides 17 centimeter. So this is the hypotenuse squared equals opposite 12 plus adjacent squared. So x squared will be 17 squared minus 15 squared. So x squared equals what? 17 squared, that's 289 minus 225. So x squared will give us 64. X will be square root of 64. That will give us 8 centimeter. So this will give us 8 centimeter. Let's look at another question. The diagonal of a rhombus measures 8 centimeter by 6 centimeter. What is the length of the side of the rhombus? What is the length of the side of the rhombus? To answer this question, we have to draw a rhombus. This is the shape. I need to draw this. Or better still, I'm not very good at drawing. I think this is better. The diagonal of a rhombus measure 8 centimeter. It means from here to here is 8. So it means one side, one of these will be 4, one of this other will be 4. And then from here to here is 6. So it means this place will be 3. And then this other place will be 3. This makes 6, this makes 8. What is the length of the side of the rhombus? So we are looking for the hypotenuse here. Let's call it x. So the hypotenuse square will be equal to opposite square plus adjacent square. That's 9 plus 16 is 25. Then x will give us square root of 25, and that will give us 5 centimeters. So x equals 5 centimeter. So the side of the rhombus is 5 centimeter. Now, there's something we call Pythagorean triple. Pythagorean triple. In the question we just talked about, you see we have something like 3, 4, 5. There's a right angle triangle. The hypotenuse is 5. Either the opposite or the adjacent is 4, and this other is 3. Centimeter, millimeter, whatever the unit of measurement. In the Pythagorean theorem, this is trying to tell us that whenever we have something like this, we could have multiples of it. What do I mean? What do I mean? If we have 3, 4, and 5, hypotenuse opposite adjacent, or hypotenuse adjacent opposite, we could have a multiplier x. X could be 2. If x is 2, we could have 6, 8, 10. X could be 3. We could have 9, 12, 15. X could be 4. We could have, if x is 4, we could have 12, 16, 20. These are all Pythagorean triple. So if we are given questions that says the hypotenuse is 10 and one of the side is 8, automatically we will know that the other side will be 6. If we are given a question that says that the opposite is 9, the adjacent is 12, we will definitely know that the hypotenuse will be 15. Or we are given a hypotenuse of 20 and one of the sides will be 16, definitely the third side will be 12. This is what is called Pythagorean triple, a multiple of the ratio 3, 4, 5. Ratio 3, 4, 5. Ratio 3, 4, 5. So the multiple, if it's 2, it will be ratio 6, 8, 6, 8, 10. If it's 3, it should be ratio 9, 12, 15. Or if it's 4, multiple of 4, ratio 12, 16, 20. Let's look at some questions to buttress this question. Now let's look at this diagram. This is y, this is x. From here to here is 9. And then we have to look for this 12. Sorry. This is 5, this is 4. And we have to look for find x and y. How do we do this? Let's label this as A, B, C, D. So we have 3 triangles here: triangle A, B, C, triangle A, B, D, and triangle A, D, C. Now, how do we find this triangle? let's say in triangle ABC, triangle ABC, y squared will be 12 squared plus 9 squared, 4 plus 5, 9. So y squared will be 144 plus 81. 144 plus 81 is 522. So y squared is 225. Y is the square root of 225, and y will give us 15. So we have 9, 12, 15. This looks like a triple, Pythagorean triple. If we divide this by 3, to give us 5, 4, 3. So this is an example of a Pythagorean triple. 9, 12, 9, 15. So how do we find our x? X here will be equal to s squared equals 12 squared plus 4 squared in triangle ABD. Triangle ABD. We have 12, we have 4, we are looking for x. So this will give us 144 plus 16. That will be 144 plus 16, 0, 6, 1, 4, 5, 6, 160. So x will be square root of 160. Am I making a mistake? So the square root of 160 will be, we have 16 times 10, that's 4 root 10. So that will give us our answer. Another question. We have a triangle like this. X, Y, A, B, C, D, 17, 10, 8. 17, 10, 8. And we have to find x and y. Before we solve any question, does this triangle ABC look like a Pythagorean triple? No, we said 3, 4, 5. If this is 10, this is 8, this will be what? This will be 6. So we are guessing x BC to be 6 from Pythagorean triple. Let's try it out and see. 10 squared, that's in triangle ABC. 10 squared equals 8 squared plus s squared. So s squared will be 10 squared minus 8 squared. That's 100 minus 64. That will be 16. So x will be square root of 16. Is that 36? 36. Square root of 36. 100 minus 64, that's 36. So x will be square root of 36. X will give us 6. So this will be 6. Like we said, Pythagorean triple. Then we can look for y. How do we get y? To get y, we have to look at a dilateral triangle ABD. In triangle ABD, 17 squared equals 8 squared plus, now we will not say 6 plus x. To make it easy, we'll just say BD, line BD squared. So BD squared will be 17 squared minus 8 squared. 17 squared will give us 289. 289 minus 64. So that will be 225. So line BD will be square root of 225. That will give us 15. So that will give us 15. So from here, line BD will have 15. Now, line BD equals x plus y. So y will be line BD minus x. That will be 15 minus, what is x? 6. So that will give us 9. So y is 9. So in this question, we have been able to prove Pythagorean triple. Solving, let's look at another question. Another question that is here. A chord is 3 centimeters drawn away from the center of a circle. A chord is 3 centimeters drawn away from the center of the circle. Center of a circle of radius. Center of a circle of radius 5 centimeters. Calculate the length of the chord. Calculate the length of the chord. In a question like this, what do we do? In a question like this, we draw the circle in question first. The circle in question, you have to draw it first. Let's assume this is the circle. And then we are told that a chord is 3 centimeters drawn away from the center. This is the center of the circle. This is the chord. Then a chord is 3 centimeters drawn away from the center of the circle. Of radius, that means the radius is from the circumference to the center, and the radius is 5 centimeters. Calculate the length of the chord. The length of the chord. That means from A to B is the length of the chord. But this has divided itself here. This looks like a Pythagorean triple question. Hypotenuse 5, opposite or adjacent 3, then we are looking for this other side. Let's call this place D. So, what are we talking about here? We will say B whole square is equal to line BD, DB square plus DO square. So, line BD or DB square, line DB squared will be BO squared, 5 squared minus 3 squared. That's 25 minus 9. That's 16. So dB equals square root of 16. That gives us 4. So from dB is 4. Now we have to calculate the length of the chord from one circumference, one part of the circle to the other. If from here to here is 4, from here to here will also be 4. Because this divides it equally. So line AB equals line AD plus DB. So AB equals 4 plus 4, and that will give us 8 centimeters. So the length of the chord will give us 8 centimeters. Thank you. We've come to the end of the teaching of the class of today. Thank you for your time. I want you to like, I want you to subscribe, I want you to share for as many that may need teachings like this, but for better clarification.